Okay, let us discuss the next problem. So this is 1.85. So this is problem number 1.85. So let me first draw the diagram. So this is a small sphere of mass m suspended by a thread is first taken aside so that the thread forms a right angle with the vertical and then released. So you have something like this. So there is a point, a thread is basically attached to this point, and there is a block, or you can say a sphere of mass m. So this is a sphere of mass m, and you can treat this as a point. So this is basically a point. So we are discussing the kinematics, we are not discussing the rotational motion. Now this is a thread is released from the vertical, and find out the total acceleration of a sphere, the total acceleration of a sphere and the thread tension as a function of theta, the angle of deflection from the vertical. So you have to find, so up to some point of time, let us say this block is somewhere, so this will follow a circular path, everybody knows. So this will follow a circular path, this is somewhere here, and let us say they are calling this angle as theta taken from vertical. At this point you have to find what is the tension. So we have to find what is the tension in the thread, so first part, and also we have to find, so let us say this is A, we have to find tension in the thread as a function of theta. So this is a tension as a function of theta. We have to also find the angle of deflection theta is given. Find the total acceleration. So you have to find total acceleration. Basically this will have radial acceleration and tangential acceleration. So we have to find total, that is the resultant of tangential acceleration plus radial acceleration. So we have to find total acceleration. How will you do that? So let us see. First let me make the diagram. So there is a force that is acting mg in this direction. In this direction we have force T. So if we expand this mg, so this angle is theta. So this angle is again theta. Are you getting or not? So this angle is theta. So in this direction you will have mg cos theta force. In this direction you will have a force mg sin theta. Now you have to find the tension as a function of theta. So how will you do that? So if you write equation for this in this direction, you can write it motion in a circular motion. So if you write, so let me write solution here. So if you write tension minus mg cos theta, so force towards center, T minus mg cos theta, that is force towards center, is equals to mass into acceleration if this is moving in a circular path. So mv square by r. So mass into acceleration. So I have one equation. Are you getting or not? I will have another equation if I write in this direction. So in tangential direction I can say what is the force? Mg sin theta. So in the tangential direction I have force is mg sin theta. So what will be the acceleration? So mass into dv by dt. So I can write second equation. So this is my second equation. So force is equals to mass into acceleration in the tangential direction. Are you getting or not? So this is my two equation. Now I can write one more equation if I consider the energy conservation. So what I have unknown? I have unknown tension, I have unknown velocity, and I also have unknown dv by dt. This means I can solve this equation if I write equation from energy conservation. Basically that equation you can derive from another way also. We will show that equation can be derived by using a different method also. So let us first you write down the energy and then we'll discuss later. So you see energy conservation if I apply. So let us say this energy is, or you can say this energy is, let us say this is the datum. So I can say what is the loss in potential energy. So this height is r. So this height will be, so are you getting or not? So this height is what? So if you make a perpendicular here. So this height is r, so this height is r cos theta. So this height is nothing but r minus r cos theta. So this height is r minus r cos theta. This height is what? This height is r cos theta. Are you getting? So what is the loss in potential energy? So loss in potential energy is mgh, that is mgr cos theta. So I can say loss is equals to m, so this is loss in potential energy, mgr cos theta. This is the loss in potential energy. This has to be, so this is loss in potential energy. It is equals to gain in kinetic energy half m v square. That is the gain in kinetic energy. This is what? This is gain in kinetic energy. So you see, from here I can find v easily. So what is the v? So v square is 2gr cos theta. So I am getting from third equation v square. Are you getting or not? Now you see, we have to find tension. So from 1 I can easily find tension. From 1, if I plug the value of v square, so t minus mg cos theta is equals to m, v square is nothing but 2gr cos theta. This divided by r, so r cancels out, so we will have t is equals to 3mg cos theta. So tension is given by this equation. As a function of theta, you can write tension is equals to 3mg cos theta. Now let us see, if I know tension, I have to find radial component of acceleration. So ar is nothing but v square by r. V square I know, that is 2gr cos theta. So v square by r is 2gr cos theta divided by r. So this is 2g cos theta. So this is the radial component. What is the tangential component of acceleration? Tangential is nothing but dv by dt. And this dv by dt you can see from this equation, this is simply g sin theta. So this is g sin theta. Are you getting it out? So this is simply g sin theta. You see, force towards the tangential direction. So what is the force towards tangential direction? This is mg sin theta. What is the mass? M. So what is the acceleration? Force by mass. So mg sin theta by mass. This will give you acceleration in the tangential direction. So acceleration in this direction is basically g sin theta. So you see, if you have theta as a function, this is g sin theta, and v square by r in this direction you have. So you can calculate total acceleration. So total acceleration is nothing but under root ar square plus at square. So this becomes g square sin square theta, this one, plus this. So this is 4g square cos square theta. So now if you take 1 sin square theta, so this becomes, let us take g common. So sin square plus theta plus cos square theta 1 plus 3 will still have, so 3 cos square theta. So let us copy whatever we have said and then we will go for the next part. Anybody having any confusion? I don't think so. So let us copy this one. So we have written two equation and one energy conservation equation. Basically, energy conservation equation can be found using a different method also. We can prove here itself the equation of energy conservation can be found using a different method. So you see this equation, that is v square is equals to 2gr cos theta, I can find using different equation also. So let us see how can we find. So let us see another approach by which the same result we can find. So we are discussing something, another approach. To find v square, this is equals to basically 2z. So here you have, so v square is what you see here. So you are not able to see now. So this is v square. So 2zr cos theta. So let me rub this one. So this is v square is 2zr cos theta. I want to find v square is 2zr cos theta. Now you see, if I take the equation of motion in tangential direction, what we have? Mg sin theta equals to m dv by dt. So mg sin theta is equals to m dv by dt. This is the equation of motion in tangential direction. M cancels out. Now I have g sine theta is equals to dv by dt. So let us make variable change, dv by d theta by dt, and d theta by dt is omega, and omega is equals to, so I can write g sine theta is equals to dv by d theta, and d theta by d theta omega, and b is equals to, this is a case of pure rolling, so b is equals to r omega. So I can write omega is equals to b by r. So g sine theta is equals to b by r dv by d theta. Now if I take d theta this side, sine theta d theta is equals to, let us take r this side also. So this becomes b dv. I can integrate. Are you getting or not? So when theta is 0, velocity was 0. So when theta is 0, velocity is 0. So here you have, so you see, okay, no, theta is 90 degree. You see here, when theta is 90 degrees, so theta is 90 degrees, somewhere here, velocity was 0, but because it's sent initially. So when theta is 90 degree, velocity was 0. Now I have to find when theta is theta, what is the velocity. So this is my target. Now if I integrate, so integration of sine theta is minus cos theta. I have to integrate from 90 to theta. This is equals to v square by 2, because at 0 you will have 0. So this is simply v square by 2. So this becomes rz, and cos theta, so minus cos theta and minus cos 90 0. So this is v square by 2. So v square I am getting here is minus 2rz. So minus 2rz cos theta. Now I have a problem. You see, I am getting a minus sign. You see, I have done everything correctly. Why I am getting this minus sign? Because at 90 the theta v is 0. When theta is theta, v is v. And integration of sine theta is minus cos theta, everybody knows. When cos is 90 theta, this value is cos of minus theta and minus 0. So this is minus. So why I am getting a minus sign? Can anybody tell me? Any idea? Anybody help me? Basically you see the problem we have. So here, if I am writing, so this g sine theta, basically problem I have, that the problem is here. You see, this force mg sine theta is reducing theta, it is not increasing theta. This force is reducing theta, and that's why if I am writing force is equals to mass into acceleration, so I have to put a minus sign here. Are you getting or not? Since this force is reducing theta, if I have taken this theta, then no problem, because in that case this theta will increase, this force will try to increase. You see, if you have a force that try to increase the value of x, you call this as a positive. If the force try to reduce the value of x, then you call it negative. Same thing here. Are you getting or not? Here you have this force try to reduce this theta, so I will have, there is a negative relationship, force and theta and force, basically there is a negative relationship. But if I take this theta, and that's why you have to put a minus sign here. Now you see, and if I want to find this up to here, I don't have any problem. So here also I don't have any problem. Simply I have to put a minus sign here. But if you take a square, you will get the same thing. So what I said in the first, this is I have done basically a mistake, and that the mistake is done purposely. You see, I want to show that if you dv by dt and the force both are not in the same direction. So if you see, this force try to decrease the theta, and that's why you have to put a minus sign. So if I plug this minus sign here, so let us go to the next page. If I plug this minus sign here everywhere, so if I plug this minus sign, you can change your, if I plug this minus sign everywhere, so finally what I will have? I will have 2gr cos theta. So this result Either I can get through integration, so I have got this integration. You can also get the same result through energy conservation. So why I will go through so much tedious work doing 2 times integration? It is always easy. So it is always easy to do energy conservation. So always easy to apply energy conservation, so conservation of energy COE, rather than integrating 2 times. Not only one time in this case, integrating 1 time. So this is, now let us read the B part of the question. So this question also has a B part. So let us go to the B part. So you keep copying. So what the B part says, so B part is basically use of the first part. This says the thread tension at the moment when the vertical component of a sphere's velocity is maximum. So when find out the tension, the thread tension at the moment when the vertical component of a sphere's velocity is maximum, when vertical velocity is maximum, this you have to find it out. Find the tension at the moment when the vertical velocity is maximum. You see, at any point of time, this is a sphere, this has a velocity in this direction. So now you know basically velocity is given by, so v square is, you see we have already derived 2gr cos theta. So v is under root 2gr cos theta. So velocity in this direction, of course this is moving in this direction, this angle is theta, so this has a velocity in this direction. So what is the component of velocity in the horizontal direction and the vertical direction? So in this direction, vertical direction, so if this angle is theta, this angle is also theta. You see angle between line is equals to perpendicular. No, this is not theta. So this is 90 minus theta. This angle is theta. You can prove. So this is the line. Onto this line, this is the perpendicular. This is the line onto which this is the perpendicular. So this angle is theta. So if this angle is theta, this angle is 90 minus theta. Are you getting or not? You can prove this one. You can basically make a triangle. So this is theta. This is 90 minus theta. This is theta. This is again 90 minus theta. So what is the vertical component? So this is v. This side will have v cos 90 minus theta. So you will have v sin theta. So in this direction. So what is the total vertical velocity? So vertical velocity you have. So vertical velocity will be, you see vertical velocity will be v sin theta, and we know v is nothing but under root 2gr cos theta multiplied by sin theta. I need the theta when tension is, vertical velocity is maximum, so I have to differentiate this one. So let us call this as a vertical Vy, sorry, so By, so dV by d theta, so basically By is a function of theta. I have to put it this as a 0. So you see this becomes simply, so 2gr I can take always common, under root 2gr. This is cos theta root and sin theta. So I have to differentiate this function. So if I differentiate, so sin theta is cos theta, keep under root cos theta as it is. Now we have differentiated sin theta, I have to differentiate cos theta. So root x is 1 by 2 root x, and cos theta is minus sin theta, and there is again sin theta. So this is a differentiation you can always do yourself. Are you getting or not? So this becomes cos square theta is equals to 2 cos square theta is equals to sin square theta. So this becomes cot square theta is equals to 1 by 2. So cot theta is basically 1 by root 2. So cot theta is 1 by root 2. So this is the time when the vertical velocity will be maximum. So at this time, what is the tension? So you see we have expression for tension in the back page. So you see what is the expression for tension? You see your copy. Let me see. I have also. So I have this expression for tension. Tension is what? 3 mg cos theta. So tension is 3 mg cos theta. And cot theta is 1 by root 2. So I have 1 by root 2. So cot theta. So cot theta root 2 by 1. So this is how much? Root 3. So root 2 a square and this. So this means 3 mg. Cos theta is the. So this angle is theta. Cos theta is how much? Root 2 by root 3. Are you getting? So root 2 by root 3. So this is the value of tension at this point of time. Are you getting? Now we have the next part also. So next part, part C. What this part says. So the theta between the thread and the vertical movement when the total acceleration vector is directed horizontally. So this says find theta is equals to what? When total acceleration is directed horizontal. So acceleration is horizontal. Acceleration is horizontal. So if the acceleration is horizontal, this means what? Vertical component of acceleration is 0. So total acceleration is horizontal. This means vertical component is 0. Vertical component is 0. So what is the vertical component? So this, if this is moving, I have to take one more page. So let us go fast. So if I take this one, any point of time, this block, angle theta, has a one acceleration in this direction, that is g sin theta, and one less acceleration in this direction, v square by r. And v square I have already derived. At any theta, v square is given by 2gr. So you see here, v square is given by 2gr cos theta. So v square is 2gr cos theta. So this becomes 2gr cos theta by r. Are you getting? So this is simply 2g cos theta. So I have to have vertical component. So question says acceleration is totally horizontal. So vertical component is 0. So I have to take this vertical component and put it 0. So this angle is theta. We have already derived. This angle is 90 minus theta. And this angle is what? So this angle is 90 minus theta. This angle is 90. So this angle is theta. Are you getting? So what will be this component? So this component is v square by r cos theta should be equals to the downward component, that is g sin theta, and cos 90 minus theta, that is sin theta. And v square is given by 2g cos theta. 2g v square by r is given by 2g cos theta. So this is v square by r. So 2g cos theta into cos theta is equals to g sin square theta. So once again g cancels out. So we will have cos square theta is equals to cos square theta by sin square theta is equals to 1 by 2. So once again you have cot theta is 1 by root 2. Let us copy this one fast and then we will discuss this question. Okay, so I think we have copied this one. So what we have said, the last part I have gone slightly fast. You see, this acceleration v square by r will have a component in vertical direction. In this direction it will have a component. And this acceleration g sin theta will also have a component in this direction. So now this two component must be added up to be 0 because question says there is no vertical component. So vertical component this plus this, if I add, it should be 0. The vertical component is v square by r, and then this angle is theta. So this is v square by r cos theta. This is g sin theta. This angle is 90 minus theta. So this is g sin theta cos theta. Now I am not doing anything. V square by r is 2g cos theta. So this becomes 2g cos theta into cos theta, that is 2g cos square theta. This is equals to g sin square theta. So I am doing the simple calculation now. So you are getting this cot theta is 1 by root 2. So in the last part, so you see we have found tension. In the B part we have found tension, and tension is coming out to be under root 3 mg. So you see I have to check the answer. I don't know whether I have not checked the answer. You check the answer whether it's correct or not. If not correct, you satisfy yourself where is the mistake. Okay, so basically you see in B part I have a correction. I have kept this is root 2, this is basically 1 and this is root 2. So this will become cot theta is root 1 by root 2. So here you have cos theta is 1 by root 3. So 1 by root 3. So this is the correction you can make. And this becomes mg by root 3. So the total tension is mg by root 3 if I see the solution. You can verify yourself. Yes? Cot theta is 1 by root 2. This means this is cot theta is base by height. So this is base is 1 unit and this is root 2 unit. And then if you do this one, you will find the answer. So this is all about this problem. This is the lengthiest problem. So there is a correction in B part. So what is the tension when the theta is basically in this drawing I have some mistake. Okay, we'll go do for the next problem.